Hello. So in this video, I am going to show you how to make the connection between f prime, f double prime, and f. This is a super common question that I get all the time from my students. And I'm going to nutshell it here for you. This is the hardest situation. When they show you a graph of f prime, that's important to note, and then they're asking you questions about f. See, in every single one of these, it's talking about f. Where does f increase? Where is f concave down? Etc. They'll always be asking you questions about f, 99% of the time anyway. So here's how this works. All of these first group of questions where it's asking about increasing, decreasing, maximum, minimum, when you're looking at f prime, you need to look at where f prime is above, below, or touching the x-axis. That is all you're looking at when you are looking at f prime and answering those four types of questions about f. Okay, so let's take a look at f prime. I'll highlight it. The above the x-axis portions, let's highlight that in green. So it's above the x there, it's above the x there, and it's still above the x right there. Any place where it's above the x-axis, that would be a place where f of x was increasing. Because those are places where the slope on f was a positive value. So I am going to move a little bit of this around. Okay, so I just made a little more room for us. So for part A, the places where f of x is increasing, well, that would be from -5 until -2. That's the first interval. Union. Then it picks up again with increasing from 1 until 3. And then again from 3 until 5. And you can't just say right here, you cannot just say 1 until 5, because at 3, it's not increasing. Because right at 3, it's touching the x-axis, which means something else. Okay, so that's why I did that. Let me get rid of that so we have room. All right. Okay, now let's highlight the places where the graph of f prime is below the x-axis. It's only those two spots. F prime being below the x-axis means that f was decreasing, because it means that f had a negative slope in those portions. So my answer for part B, f of x is decreasing, well, that is all the way from -infinity until -5. And then again, below the x-axis from -2 until 1. So those are the spots where f is decreasing. Now our goal is to find where f has a relative maximum, and for part D, a relative minimum. Well, a maximum, that would be any place where f goes from increasing to decreasing. Because if it increases and then it decreases, that's going to create a relative maximum. Now we know where it's switching from increasing to decreasing, because that's where it's going from green to blue on the f prime picture. So one place where that's happening, switching from green to blue, is right there. I'll make that nice and big. And actually that's the only place where it's changing from green to blue, meaning green to blue, just meaning that it's going from above to below the x-axis, which meant that f was going from increasing to decreasing. So the only answer for relative max would be x equals -2. All right, now think that same way. A relative min would be any place where the original curve f, which we do not have a picture of, goes from decreasing to increasing, because then f would be decreasing, decreasing, and then increasing, increasing, and right there you would get a relative minimum. So on our f prime picture, that would be any place where it was below the x followed by above. So that would be from going from blue to green in my highlighting. So from blue to green, that would be here, and that would be here. So both of those points would be relative minimums. So that would be x equals -5 and x equals 1. So those are the two spots where there would be a relative minimum on f of x. Now we need to think about concavity and inflection points. So these last three questions, whenever you're looking at f prime, you need to be focusing on where f prime, look at where f prime has positive slope versus negative slope, and where it switches. Oops. Okay. So if I highlight the places where f has positive slope, f prime, I'm sorry, the places where f prime has positive slope, one place would be from there to there, another would be from there to there, and finally from there to there. Now a positive slope on f prime tells you that the original f was concave up. That is because, let's label that first, f of x concave up. And that's because this would tell us that f double prime was positive. And anytime f double prime is positive, that's our test for if the original f was concave up, or if f double prime is negative, then f was concave down. But we're just trying to connect f prime to answer all of these. So just keep in mind, you're looking for where f prime has positive slope, negative slope, and where it switches. That will tell you concavity and inflection points. Okay, so I just made a little room for our answers. So I highlighted the places already where f prime has a positive slope. So those are the places where f is concave up. So concave up, the answers would be -∞ until right around -3. That was the first section. That was in the yellow highlighting. Then the next portion was from -1 until 2. And the final section, union, 3 and onwards. So 3 to infinity. Those are all of the intervals for x where the f would be concave up. Now if we focus on the spots on our graph that have a negative slope, that would be there and there, just those two spots. Those are the spots where f of x is concave down. So concave down, my answers would be from -3 until -2, or until -1. That's a negative slope all in that region. And then from 2 until 3. And those are the only two spots where it's concave down. Now, inflection points are places where it changes concavity. So that would be any place where it's changing from yellow to green. So I'll draw those in nice and large. One place would be right here, and that's at x equals -3. So that is one inflection point. Another place where it switches is at x equals -1. Another place where it changes from positive to negative slope is at x equals 2. And the final place where it changes is right there at x equals 3. Now, we don't have any way of knowing the y coordinates, so all we do is write down the x coordinates of the inflection points. And that is it. So let's just summarize everything. When looking at f prime, okay, you need to look at number 1, above, below, and touching the x-axis. Okay, just try to keep that simple idea in the front of your mind. What it tells you, above tells you f increasing, below tells you f decreasing, and touching the x-axis tells you potential, max, and mins. Then the second big idea to keep at the front of your mind is to look at, when looking at f prime, number 2, look at where it has positive, slope, negative slope, and where it switches. I'll say where it changes, like positive to negative, or vice versa. All right, because a positive slope on f prime is telling you f of x concave up. Negative slope, f of x is concave down. And where it changes, that's telling you where f of x has inflection points. And there's a lot of different examples that we could do on this subject, but I'm just going to leave this at this. And if you can really let this sink in and know how to connect when you're looking at f prime, what is happening exactly on f, that's going to be the number one thing that I want you to get out of this video. So this is looking at f prime, that's a prime, looking at f prime, answering questions about f. And that is it.